All right, one more program that I want to show you is called SuperCollider. This is also a free program which you can download. And here's the website. It's supercollider.sourceforge.net is where you would get the code and so forth. And you can get it for Mac, Linux, or Windows. There's also a book published by MIT Press, if you really get interested in this, that is very thorough in showing you lots of information how to use the program. It's a very powerful program. This one is a little bit different in that it is a little bit more code oriented than object oriented in this. So it says here it's an environment and programming language for real-time audio synthesis and algorithmic composition. Provides an interpreted object-oriented language which functions as a network client to a state-of-the-art real-time sound synthesis server. So maybe a little bit confusing, sort of what that means if you don't know what this is doing. So let's go straight to the program and I'll show you sort of how it works. So when you open up SuperCollider, you basically click on this. The first thing you'll see, well, first of all, is this screen, which tells you it's compiled and loaded. You need to assign the local server and the internal server, and I won't explain that too much right now, but you just turn these on. And then I've opened up basically some code to show you how it sounds. So here, for example, if we look at this, anything in the parentheses is going to be what is being compiled in this. So we have the first parentheses, and then we have to look for the very last parentheses here. So everything between those two will get compiled. So all I have to do is double click, put my cursor there and double click, and then it will compile everything. So if I double click there, you'll see it highlights all the code in between these two parentheses. Now just quickly, what's going on is assigning a variable, a scale with a buffer for that. Anything in red is just a comment after these double slashes here. So this is not really code, it's just information about what's going on. So it then defines, we have a variable, a scale, and a buffer. So then the scale is defined as a floating array, and we have the specific numbers of that particular array, which happens to be a Dorian scale. That's what's being assigned. And then we have allocate some buffer size, and then it tells us the size for that, and so forth. So then we're going to be creating a sine wave oscillator. And in this one, we're going to also create a mouse X controller, which allows us that once we assign the scale, we'll be able to trigger the scale just by moving my mouse across the screen. Will move us up through this array here. So, and then it also creates drones, you'll see here, and then the play at the end. So once you do this, you just hit the enter command, and you'll see here we hear the drone. And then I'm going to move my mouse so you see the scale, the floating array that's here. That's the pitches that we've assigned, our Dorian scale. So obviously creating a little bit of a Indian, kind of classical Indian raga feel there. Here's some other simple examples that come with when you get the software. Very simple. So on this one, see, this is all the code that's being set up here. Basically, it's a glissando function and then sort of echoing the sine waves here. So very little code, and that's being set up. I don't have any kind of mouse controller on this. So listen to it's just a. So just a simple sawtooth waveform that is ascending with these kind of MIDI assignments to it. So nothing very complicated there. Let me just kind of jump through a few of these. Let's see, what might be interesting down here lower. Okay, let's try this one, reverberated noise bursts. So you see just the code from here to here. We've assigned some variables, and then essentially a pink noise percussion sound is what we were creating here with this dust argument here in the pink noise with that. A little bit of a delay added into it, and then 6 modulated comb delays in parallel as part of this information here. and then running it through an all-pass filter. So as you can see, it doesn't take much. Once you learn a few of these commands, each of these particular objects has obviously a lot of code behind it. If we wanted to sort of see what is the prototype for that, so like the low-frequency sawtooth waveform, you can come up here and look at the class definition for that. We could open that up, and it would show us here what are the arguments in that, and also similar kinds of definitions in that same class. If we wanted to substitute some of these, we could choose some of these other ones and for that same one. So you can see there's a lot of different variables that are simple to use here, but most of the time in this one you're not necessarily using the object like you are in Max and Kima, but a little bit more of the code. So this I can control with the mouse, the filter, the low. So we have an X and a Y on that. You'll see I've got the depth on my Y-axis, and then the X is the rate. So it slows down the rate if I go the horizontal, speeds up the rate, and then this is the depth. Controlling a filter on that. So very simple kind of routines on this, but they get more complicated as we get down into a little bit more code here. I'm not going to take too much time, but I think I would encourage you to download this program and start playing around with it. Here's one that the inventor of the program, James McCarthy, created. So if we, for example, if we click right here and I hit compile that, you'll see we already have the localhost running, but that's how I would assign that. If I put something within the parentheses, so for example here, when we compile this, we're defining just the reverb. So you'll see that has been defined. There's a synthesizer with just the reverb put into it. You don't hear anything yet because I don't have a play command. Then go ahead and compile this next section, which creates 100 randomly generated FM instruments, percussive instruments. And you'll see that's the amount of code that is doing that. So when I compile that, takes just a second. Then over here you'll see all the different 100 different kind of percussion sounds created. Then finally I access those in this final object, and I have a random generator which will generate different kind of pitches for that with certain kind of random parameters. So when I finally hit the play, so this composition is randomly running, and I don't really know what's going to come next. But if I wanted to come up and start to play around with some of these variables of sort of how much some of the filtering of that, or how long the particular articulations are, as you can see, it has its own sort of logic to it built in. So another kind of a little bit more sophisticated, where you can sort of see where you define the instruments, you then define the playing of or the score for that are done separately here. So without getting too much into SuperCollider, I just wanted to show you just the essential basics for how this program works. It's a very powerful program. A lot of people, this becomes the only program they work in for sound creation and sound design. And I would recommend, if you're interested in doing this, it's really a wonderful program to explore. So that's SuperCollider.
The preceding program is copyrighted by Emory University.